So I will start this second day with a presentation on Pharo 12. So it will be shorter than normal. So like that you can prepare all the questions that you want to ask, and then we will try to answer them. So I want to thank all the industrial partners of the consortium, and I'm sorry if I mess up with some missing logos. I hope not. So this is what I said. I will just explain to you a bit what we did, because sometimes we work in the and it is unclear what we are doing in the back. And take your time, and then the people of the team can reply to your questions. So yes, Pharo 12. Yes, we work a lot. In fact, nearly 2,000 pull requests in 900 issues. And this is just in the Pharo repository, so we have several of them. So yes, it was quite a lot. So if you follow the mailing list or the blog, Marcus is always posting all the things that we do. And also, we also backport things. So we backported a lot of things to Pharo 11. So now the Fluid syntax is by default, and it works super well. It helps us to remove a lot of strange code, old code, and things like that. So I would really encourage the other Smalltalk to pick up this syntax, because this is also a builder. So the lesser is a message that creates a class builder. So this means that with this class builder, we can do a lot of things, because we can create a class without installing it. We can have the class in your hand and do tricky stuff with that, and then we can decide if we install it or not. And that's a super nice property, because like that we control side effects. So we got, I don't know, Chris is here. Yes, Chris, thanks a lot. Yes, you can. Yes. So just to tell you the story. So in fact, we are doing a monthly sprint. So basically, all the team get into the corridor, and then we have candies all over the place. And then we have people from École des Mines de Douai, where are they? There, Nouri and some people, and Luc, that are coming to hack with us. And we have also people from YesPlan, because they are close by. And then we have fun so this is the last Friday of the month. If you are interested and you are in the neighborhood, you can join. And Chris is really improving the fonts. And my eyes are not crying anymore, so this is good. Thanks a lot, Chris, for that. We did a massive cleanup. When I said massive, I don't know where Cyril is, but during 6 months, every day, he was trying to remove, step by step, the class organization. Because the class organization is something that was from the old time. What I said about the class builder is that having a class builder helps us to remove all kinds of string comparison everywhere. So now we have object. So we could really simplify a lot of things. You don't want to know this was terrible. It was working, but terrible. And then we had a much better Metacelo architecture, so I will just say 2 words on that. So yes. So what I said is that this is one bullet point in my slide, but this is really 6 months of hard work, especially because the class organization was used everywhere. Now, you would say, oh, I don't care because this is the internal of the stuff. No, you get impacted because now we have super fast tags. Before, especially for the people that were using block, when you use a lot of tags, it was super slow. It was optimized in Pharo 11, but it was slow. And now this is at the right speed. We also optimize all the memory usage for the protocol and things like that. So we are super happy about that. It was really, at some point we had a joke inside the team that said, oh, maybe the data structure to use class organization was invented before data structure. Because suddenly we replaced the logic with a dictionary, and poop, it went fast. So it was like, aha, okay, now we understand. So that was a joke, but nearly true. So we started to look at Metacello code, and now there is no exception resume anymore. So, by the way, we should never do that in your code. Don't do that to yourself. Don't use an exception, do a side effect on something and resume it. Because, you can just pass an argument or you can pass an instance variable instead and then you get the same. So we don't, now Metacello does not walk the stack and jump there. So we got a nicer architecture, a better domain. So now we understand the phases and things like that. So we will be able to do other things. So what we are doing in the back, we are trying to do, or we did some experiment, package validation. So this means, can I load the package without installing everything in the system? Check my package. Oh, is it nice and good? Are you a nice package? And then we can decide, oh, I want to install you or not. So we needed to control these things so that we can explore. For example, we want to have in the future a strict mode loading to say, okay, you are a package, a nice citizen, don't do crazy stuff, and we guarantee that you do not have undeclared or things like that. So we really want to have this hook so that we can improve the infrastructure. So now we have this in Pharo 12, and we can start the next iteration. So you saw the presentation of Steven on the debug points. So for us, the debugger is really where we code, where we live. This is our best friends. So we really want to improve this. So revisiting basically breakpoints was the topic and said, oh, why the breakpoints are so strange before? And then the funny story is that there was this student and I said, oh, we should work on breakpoint. I want breakpoints that are much better. And at the end, they have a nice, simple model, and the student was disappointed. Oh, this is too simple. And we were like, no, this is too cool. So we have a simple model, and that's nice because we have to maintain it. Huh? So, and then again, we want to build, we have all kinds of ideas around the debugger, so we will start to work on that. So we didn't present this, but if you want, you can ask a demo to Sebastian. So Sebastian is working on a scalable memory profiler. Because the problem is that the memory profiler, sometimes they work, but as soon as you have a real application, they do not really work. So we did a lot of things with ephemerons and computing things. Can we do sample to really get information? Can we know what are the plays that are generating instances? Because this is easy to say, oh yes, this class creates a lot of objects. Good. And then we want to know where. Only in one source, in multiple sources, and things like that. So this is part of a general effort of rethinking the profiler. We want to have better speed profilers also. We did a lot of experience, internal experience, to understand what is it, how the garbage collector influence the speed profiler also, and things like that. What are the heuristics so that we can give you better information on your system. Guichet will present something on also something that we did. This is, can we understand the behavior of the assembly code that we generate? Can we profile these things? And we were surprised by the state of the industrial tools out there. So for the refactoring, so yes, last year Balcha presented the first iteration of a new architecture for the refactorings, and now we take advantage of that. So we did another iteration. You know, we have 70 kind of more multiplied by 2 refactoring and transformation, and then now we are migrating everything. So what we are doing is that we have one object that is responsible to drive the interaction with the user. Because before it was inside the refactoring, and this is not what we want. So in fact, we want to be able to have a refactoring engine that we can script on the command line if we want, or that script because you want to transform your code, but we want also a much better user experience. And this is the goal of the driver, because in the original refactoring implementation, this behavior is inside sometimes the preconditions. I don't know where they are, but they are at the wrong level. The precondition should not do pop-up, open a browser. No, not anymore. So we are killing them one by one, all these guys. So this is a lot of work because, and now we are getting to the moment where we understand. We want also, yes, something else to explain you. We just don't do that for doing it. We do that because we want that you are able to program your own transformations and manipulate them. So for example, extract methods. If you take Pharo 11 or Pharo 10, you can have fun, try to read it. The steps, we did a bullet list with the steps that are happening. This is a full page of steps. And this is monolithic. Now in the Pharo 12, this is a modular system. So this means that the extract method is composed of 3 operations. And then this means that, oh yes, we can recompose this operation. We want to have extract setup that should not be another monolithic implementation that should reuse and compose operations. So that's why what we are doing the transformation, which are not preserving behavior, and the refactorings. And the idea is that at the end, you should be able to script things in a nice way. And we should, as a developer, interactive developer, we should have a much better experience from the refactorings. So now we are working, for example, on inline methods to do the same. So we wrote a lot of tests. So basically, the implementation is often really good. So it works. So there was not that many tests. So we had a systematic test suite now for all the case for the inline. And why do we want to do that? Because, for example, in the code of the virtual machine, this is a Pharo code that looks like C semantic plus annotations. And when we do an extract method or inline methods, we want to make sure that we can say, no, when we are coding in slang, we don't want the Pharo semantic. We want the C semantic. So can we write our own transformation so that we can support the guys that are doing the virtual machines? And they could have domain-specific refactorings. So you should be able to have domain-specific refactorings. This is what we are looking for. So if you have ideas, if you have a domain, for example, a database or something like that, just contact us because that would be really interesting to see what are the domains and how can we build the tools for that. So this is basically the work of Balcha, and I could not find so Hernan. This is the only picture of Hernan that I found. So this is not Hernan, but this is on his GitHub. So I took the stuff. And for the debug point, this is Adrian. I type Adrian on Google. Apparently, this is a little character for kids, so that's perfect. So we did also code loading speed improvement. Some simplification on the Opal compiler and improvement, a much better working on a more robust and strict mode for FFI. In AWST, we will see for the FFI we have we did an analysis on with Rouhani that is there that will present that. I think that this is what how many % speed you got, Rouhani? 12. Okay, times 12 for the one that are useful. So this means that basically the FFI will get faster for you most of the time. Command line. So I don't know how many of you like command lines, but yes. So the Pharo launcher was cool. It is cool. Thanks, Christophe. By the way, this is a real application that is running in three platforms, so that we use every day, and when it does not work, we are mad. So that should be a real application. And then we were like, oh, that's cool to have this click and play stuff, but can't we have it on the command line? And with David Bajger, I don't know how to pronounce that, they work, and Christophe will show that, and this is super cool. It's super cool because you have features that you don't even have in the launcher. You can say, oh, I want to get this pull request, this image with this pull request. I want to do all kinds of stuff on the command line. So they separated the logic of the Pharo launcher into two things. One that we can reuse independently of the UI, and this is super nice. So thanks. From the VM side, we got a faster byte array comparison. I don't have the data, so you can ask Pablo and Guichet for those kinds of things. There is now unlimited sockets. We have also, I don't know what is it, ePOL for idle VMs. So basically, this is good because we don't We can have a VM that is using less your battery. In the context of the image segment, wait, not image segment, permanent space, sorry. In the context of the permanent space, now we have a new segmented image format. So this means that instead of considering the image as a big memory piece, we can have a different zone, and then we can start to have fun with this zone. So for example, I learned that some companies around here are running their test on 4,000 cores. So maybe we could share some of this memory in the segment. We can say, okay, the permanent space, for example, that does not change. Maybe we can not duplicate it in memory for all the things and share that. So now we are in the moment where we can explore new things for the next iteration. There were a lot of ephemeral performance improvement. By the way, for the permanent space, Lifeware got the test from 12 hours to 8 hours working on their server, so that's cool. There were a lot of fix, cleanup, stability. Something else that we always take as granted, which is absolutely not free, this is that part. I should have put it in red with fire, you know, like Mr. GitHub changed the libgit, and then suddenly nothing works because they patch the data structures. And of course, they do that in the summer during vacation because it's more fun to do it like that. And then people said, oh, we cannot, it does not work anymore. I said, yeah, okay, okay, libgit changed, and then what? Yes, and yes, this is a lot of work, this part. Especially what is super annoying is that we do not control the agenda. It's happened, and then we have to react. And like, but that's like that. This is life. But I thank them for that because like that we don't have to worry, but they have to worry. So, oops. Yes. So, beside that, we work on all kinds of, I don't like the name experiment, but adventure in this world. So we started to ask ourselves, okay, can we reprofile the code that is generated, the assembly code that is generated? What's happened when the code is generated? Is it doing something good or not? Where do we spend time? Because it's a black box. So Guichet was trying the Mac profiler and shrinking huge XML files to get some information. How can we take good decision and what is the information that we need? So like that, this is for the next iteration, because in the future we want to work on a dynamic inliner, but it's a long effort, so we want really to know where should we work and for which reasons. Dreid, this ahead of time compiler is now nearly ready. Huh? No? Yes. Soon. So the idea behind Dreid, this is the following. In Pharo, you have the Pharo compilers. We are super happy, this is nice. It's written in Smalltalk, lovely. In the virtual machine, you have an interpreter and another compiler. In fact, we have 4 compilers in the Slang world. And this compiler has a completely different model of execution. So when you are in the interpreter, you have variables and things like that. When you are and then in the JIT compiler, it manipulates register and things like that. So those are 2 different worlds, and we jump from one to the other one at runtime. And we try to minimize the jumping back to the interpreter. The idea is that all the primitives, all the bytecodes, they have to be expressed in these 2 worlds. So we express them in the interpreter, and you should have a version that is generating code that will generate the assembly. And the point is the question that we have as because we are software engineers, we said, oh, they are doing the same? Because maybe there is differences. So this was a paper of 2 years ago that we got accepted to the best conference in language implementation to understand, is it the same? Now, what Dreid is basically doing, this is, can we have a meta interpreter that interprets the interpreter and generate the assembly for us, which is nice because like that we could remove the part of the code that has been written by hand. And also it means that if in the future we want to extend the functionality, we can write them in the interpreter because this is simpler, and it will generate the code that generates the assembly for us. So of course this is a bit meta, but this is really interesting. The side effect of that is that when we write Druid, we have to understand what is a real compiler, not the toy that we have at the Pharo level, or that every Smalltalk has at the Smalltalk level. So, you know, SSA, single state form, I don't remember I'm really bad with the acronym. So SSA, this is a special form of your tree to make sure that you have the right algorithm in the right form. So we do passes and things like that. We do dead call elimination, I don't remember the name. So all kinds of algorithms that are basically in normal compilers with a data structure like basic blocks that are in default compilers. So the good effect for us is that first we learn the domain. We will have this translation automatically, not for free, but like that we have that. And then what we can do is that potentially we started to improve the Pharo compiler also, because we have something that is called Drupal. This is Druid plus Opal. This means that we take the algorithm and the structure of Druid, the data structure of Druid, and then the backend of Opal. And then this means that our naive Smalltalk compiler could be a super cool Smalltalk compiler. And maybe in the future, Druid would be something that will happen at runtime. So for us, this is the step one by one to learn the domain and things like that. So we work also on how can we stop the endless loop. You know, oh, Pharo does not work, it loops. No, your program makes loops. Let's think the correct way. You write loops. So we analyze the stack consumption, the stack page and all these kinds of things. And then what we see is that in average, when we run the Pharo test, we consume something like 4 or 2 stack page, which is quite small. And then Morphic can consume 18 stack page because this is super recursive. The rendering of Morph is iterative, is really recursive and not iterative. And then we were really looking at what can we do to detect that you wrote an endless loop that our system should catch. Let's not inverse the situation. And we are working on that. So we got distracted by other things, but we will come back to the story. If you want, you can discuss with Guichet on those kinds of things. We were also looking at how people are doing that in the Java virtual machine to see, okay, can we improve the things? Can we get things faster and things like that? So we are into that. So where is it? Yes, by the way, announce. We are looking for an engineer. So if you're interested, you can talk to Guichet on that. This is a 2 years contract and more on virtual machine things. So I forgot to say this slide was misplaced. So something that we want is that we don't want that you write code. We want that you write apps. You know, first, this is a lot more sexier. Apps is not code, it's apps. So that was the Pablo show at ESUG last year. And last week I was super excited because with a little script like that, I can have an app on my Mac that looks like an app and not just like plain code, you know? You know the difference between an app and code is that the code, this is in a workspace. Nobody knows what is a workspace, by the way. It's ugly, and then you have this ugly look of Pharo, and it's like, that's code. And an app, this is a nice looking app with an icon, and okay, with a voice like that, and And we want everybody to have an app. We should be app builder and not developer. So we are working on that. Esteban wants to have a builder for that. For me, if I have already a script that works, and then I just have to sign my app on the crazy Apple system, then that's perfect. But we are there. Basically, last week, I was like, oh, this is super cool. I have my app for the first time, so this is cool. So we work also on Spec 2. So after 4 years, the book is nearly there. So I guess that we have maybe a month of fixing things around. So Koen is not here, but I really thanks him because I was exhausted on this book. So you saw the talk of Esteban. So we are working on GTK4, and you saw the talk of Toplo. So the goal is really to have all the spec widgets working in all these different things, and we want to fade away morphic. So we are cutting trees and trees and trees of classes there. So the effort is on block and on Toplo there. So Esteban showed you that yesterday. So block, so Pablo showed that. So since they are recording like that, this is important, like that people can find their baby after. So, yes. So this is nice looking. And you will see also for the people that were not last year, this is a real application that has been deployed at Thales for their cells, and this is everything is done with Toplo, and it was working 8 hours or 9 hours a day on the Windows system, and everybody is super happy. So we are super happy too. And they developed that in 1.5 months, because they told me the first time 1 month, and then after they told me the second time 2 months. So I have to do the average. And I was like, wow, you did all that stuff in 1.5 months? Woo. Super cool. Before the cells were using PowerPoint instead of these kinds of... so everything that you see on the screen, this is really was written from scratch based on Block and Toplo. And this was the previous version of Toplo, because over the summer, everything got rewritten. To have the skins and things like that. And so what you see is that for us, there is no opposition between GTK and Block, because when you need to do these kinds of widgets, you will not do these kinds of widgets with GTK. But you can embed those kinds of widgets in GTK if you need. So like that, we have the best of both worlds and things like that. Yes, Toplo. So Pablo showed you that yesterday. Much better than me, so I like this. I like this video, especially the animation. We are so used to have a bad user interface that we don't understand when it can be cool, So I was like, oh yes, I want this stuff. This is too cool. Let's be modern after all these years. So. Something else, because Pharo, this is nice, we release a new MOOC after 4 years of effort, which was a bit painful at the end. But this is a MOOC. So the first Pharo MOOC was about Pharo and advanced design a bit. There is a trick. I said to people that don't really understand object, I said, yes, I will teach you advanced design. Because if I said, no, you don't understand basic design, so come to my basic lecture, they will not show up. So I said, okay, I'm expert in, and I will teach you advanced design. What is self and super? Okay, so let's start. So the trick is now, that was what we did in the Pharo MOOC, and now we are doing one that is real. So the first Pharo MOOC is the first week of this one, and then after we have design patterns and all kinds of things. And there was this guy that have this quote, and it was fun. This started 2 weeks ago, so... You can use it. This is open source, Creative Commons, whatever. 61 video, booklet of exercises. So if you want to teach Pharo and advanced design, you can use that. This is super good material. For the books, so last year we worked on those books. And this year, the books that we have in the pipeline, there is this book on Spec 2. This is 234 pages or something like that. There is a book on a reflective kernel, which is more meta architectures, how we understand them, how can we build them, and a concurrent programming little booklet. The idea is that I want that all the books that are on books.pharo.org get published for real. So I take them and I revisit them and we write new ones. There is a new book that will probably take 4 years for blocks, but it has already something like 100 or more pages. So, yes. So you see, often people complain, there is no documentation, and then you can ask them, when is the last time that you write a class comment? So I mean, you can clean in front of your house. This is always good, huh? And don't bother me, because I write books. So, okay, so this finished, and and we can answer any questions.
So I down to the endless loop detection. I don't know how Pharo currently works, but VisualWorks at least tries to allocate as much stack as there is memory. So in the end, it just crashes. So is as Pharo just the very simple thing for endless loop detection is to limit the stack, for example, to a few hundred or something stack entries, because no normal program would need it, even not Morphic. So I don't know, is currently a stack limitation, or does it also allocate endless?
So they will reply, because my reply is not politically correct. So
yes, well, the idea that we have is to put a limit to the stack and allow some process to allocate more or other process to allocate less, because, for example, we have processes, or even we have Morphic in the image, but it can be any process also from the user that has long recursions or have long executions, and they will need more space. And also the problem is always like with limiting the memory or limiting the resources is how we handle them gracefully, because we need to tell the process, okay, you have reached your limit, but I will not kill you, but I give you maybe a chance or not to recover, or how to be handled, and that can be also tricky. It's not just. So just to give some details, I actually prepare a little presentation. I will go on the show as your projects. I will take 5 minutes, because it doesn't take. It can take more. So maybe this evening to explain the details. But just some details. So far right now, the stack takes 4 kilobytes. In Java, so the OpenJDK in my machine, it takes 1 megabyte per thread. Yeah, so we are a bit behind. So Morphic takes 30 pages in the stack, so it's 30 times 4K.
Yes,
so it's thrashing the memory all the time. We can improve.
About the meta-cello investment, let's say.
Yes.
I'm always wondering, meta-cello with all this recursive processing, we know that's limited. So the real question is, what happened to Packbot? And why investing so much in meta-cello, which won't work in the end?
So, this is working? Yes?
Yes, you have to be this close.
Oh yeah, this is, no, give me that guy. This is, yes, I don't want to eat it. So this is a good question. So what we saw is that we got difficulties to deliver Packbot, mainly because Christophe was working on command line, not command line, on the Pharo launcher and the command line things, and switching task is always the best way to lose your time. So then we really needed to do our experiment for package validation, because we had something that we really wanted to check that. So Guichet said, okay, let's try to see what we can do. What is it meta-cello that is the problem, and things like that. And he did a pass. And now what we will do is that we will, we didn't find the time to reunit Packbot and what we have with meta-cello. We extracted a domain. Said, okay, this is a spec, this is the validation phase, this is da-da-da. So, and we will see. So, but we were just pragmatic. We said, okay, it is working, all our systems are working, so we cannot now jump into Packbot and ask the community to migrate and things like that. So what is the path that would be in the middle and that we can still decide after and see? So I would prefer that we jump and that we have something that is working, but we cannot break the ecosystem just like that. So it was like, So let's try to see what is the smart step to enable the next step.
A question on the how do you call that, package validation. So a lot in the Python world, for example, it's quite dangerous. So in what term will you foresee kind of static analysis, etc.?
So to me, so if you read the vision paper of Pharo that I should rewrite because we achieved some part of it, there is one part that we always put it aside because it was not urgent, and then you know how it has happened. So what I would like to have, I would like that first for if you have a project, I want that when I want to load your project, I want to know, are your tests running, are your validation running, are my validation on your code running, okay, and things like that. We are not yet there. So to me, this is the project validation. For the package validation, what we wanted to see, this is what kind of tool can we do so that when we load the code, we can analyze, oh, you are extending this package there, maybe you should not. Oh, what is the dependency? Oh, why there is this undeclared that is resolved at the end of the loading? What are the feedback? Because right now, this is a big blob. You said, oh, I load the package, and if you open the transcript, you get afraid. And we want to validate those kinds of things. And we want to be able to think what we do for the code. And that's why we did that. We need hooks so that we can inject knowledge and build experiment. And we are more in this phase now. And still, I would like to have a project validation. So that's why also if you put it in perspective, what Guichet showed with the mutation testing, this is, okay, we have these tests, they're super important for us. Are they any good? So like that. And we want to do it at the ecosystem level. So this means that every package, our goal is that every package in the Pharo ecosystem can be super easy to press a button and then you get the stuff running, you get all your tests. So that's why the integration continue is super important for us and all these kinds of things. Richard, okay.
I have a question about what does it mean to build apps? Will you have tools to encapsulate a certain package and along with the executable? Is it that way? And what I saw in the slide is you called it Win Down app. Is it
Windows
expected behavior of Windows apps?
No, it's a typo. So can you? So I answer the politic answer, and then Pablo will tell you the truth. You know. So right now, so basically Pharo, since we bootstrap Pharo, you can have a really mini image. We can have an image without the compiler. So you can decide, oh, I want to load the compiler and do tricky stuff and have super minimal application if you want. But by default, for me, even I would be super happy if I have a large image, which is 50 megabytes. Huh? So if you check the size of your app on Apple, we have the time. So the first thing this is, can we package that with the virtual machine, the image, the stuff, and that it has a nice icon, it is integrated into the OS platform, and I double click and I look like an app. After we can clean the shit. Let's call it like that. Huh? So, because sometimes we are too deep first. Oh yes, this is not perfect enough, and then you die there. So I want something that works. So, and then Pablo can reply to the technical part.
Well, what we want is is having an application that is easy for the user, and it looks like something else, and it's not alien to the rest. And for doing that, there are some technical issues that goes from having a package that we are able to sign or verify depending on the target platform, have a version that we can ensure that is not modifiable, or that we can embed the image inside, that we can handle the having a read-only version of the image, and that only works in memory. And there is a lot of other things that goes from login to the user experience or the integration with the common tools in the system. So when we are talking about doing an application, it's being more inside the world of the operating system that we are running on, but without losing our powerfulness. And sometimes being strange is good, and we have a lot of things that make us better. But if we are too strange, the entry point for the users, and especially when we want to develop things for third people, if they have to install and we have to say, okay, you have to download the VM from here and the image from here and run these scripts, and then you will have this image that should need to have some special permissions, because the development version, so it will try to write in your document folder, but that's not good when we want to have an application. So what we want to do is basically integrate us better with the world, with the OS. It's difficult because it changed from each OS. We have at least, I don't know, 12 different ways of integrating because we have the Windows and Mac. That could be, it's not easy, but at least they are more controlled. And then you have the infinite numbers of Linux distributions. And I don't know. And like that, it's not easy, but what we want to do is go in that path. And you can see in the last 3 or 4 years that we are going in that direction, little by little, adding the building blocks to get there.
And something really important for me, because sometimes we discuss with the team, and I said, can we do that? They said, yes, we can do that. But for me, this is not the answer. This is, can Mr. Everybody do it? Because I can guess that you can, but me, not. So if I cannot, this means that a lot of people cannot. And the point, this is what we want, my goal is that next fall, or this fall, my dummy student can deploy an app. It will crash, because they make crash everything. But you see, so that's the vision behind. This is not just one super developer that should be able to do something, but everybody should be able to do that.
Can I ask the status on the missing keys on the Mac? I hit it last night. I spent 20 minutes trying to debug something, and you know what? My method hadn't saved because Control-S didn't work. I know someone was working on it. Is there any update on that? The random missing key whenever you go into Pharo? Yeah.
Yes, I have found it's an issue. Yes, I know. I have found an issue in SDL. I have done a pull request in SDL. They are taking longer. I have to release a version with a patch version of SDL because I have in plans to do it before just throwing the bomb before holidays.
Okay, you see.
Like that, we do
external leads.
So many people going crazy.
Yes, but it's a long-term issue, and it's something that is not affecting SDL people because mostly of the users of SDL, they are not switching Windows unless you are switching from your game to something else at work.
Aha.
So I had a good question, as you said. I can make a bad one, maybe. Can you elaborate the way to block? So the Pharo without a morphic. So, I mean, we have block, but you know what we want, because we want to have Pharo in block. So what are the blocking things?
Okay, that's
for having block.
Okay. So so basically we did. we did an analysis of, you know, sometimes you believe that the world is in a certain shape and it is not. We said, oh wow, I thought that we were using spec for that. No, we are using morphic. So the goal right now, this is to kill all the, because morphic, this is two things. This is the low-level things and this is the widgets. So the first thing that we are doing, we are killing, rewriting in spec all the widget level tools. So basically, we should be able to remove the widget for morphic, because like that, it will prove to us that all the tools have been migrated. So this is what we were doing. For example, the message list, the message browser, we were like, oh yes, no, it is in spec. Ah, no, it is not. Ah, okay, so let's do it. So now there is a big building blocks on the road. This is Calypso, because Calypso was never written in spec. So what we will probably do, this is check if we can encapsulate it in a window where this is the only morphic tool left. Like that, we have a migration path, and then we eventually we take our hammer and beam, 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 and then we rewrite it. So that's basically the plan. But for that, that's why we need this spec Toplo, and we need and also to give a feedback loop to Alain, because so he has the feedback loop from the Thales people because he's working with them for all the widgets and things like that, and the skins. And what you should realize is that Toplo, this is the second iteration. After last year ESUG, they rewrote from scratch everything. Because the architecture was not correct, blah, 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 the skin now is, and it took them 1 year of stabilization, and now this is, now we know that this is good, because this fulfills their scenario, so it will fulfill our scenario. Because for Pharo, that will be just a skin, or a theme. So I think that we are in a good shape. Now we will give feedback to Alain, because in spec we have tests. He has tests in Toplo, but we have also tests in specs. So like that we can know, oh, is your widget compliant with the backend, that what we expect from the backend, and we have a nice feedback loop. So Martin and Pablo, they are giving feedback to Alain. Alain is fixing stuff in, I said, oh yes, the API could be nicer like that, and I refactor it like that, and things like that. So we are creating a nice feedback circle, and I hope that we will have something for December, so that we have a nice spec Toplo backend, and that's the objective. And in parallel, cutting all the strings that we have to morphic widgets. The last one? No? Coffee. So.